So 15% of the total download bandwidth is taken up by Netflix. I don't know if you've been like me, but on lockdown especially, there's been an increase definitely in my house of Netflix, but that was taken in 2018, so I'm sure it's a little bit more now even. Uh, so um, this is the infrastructure that goes behind all of these downloads. So this is it's called a Death Star map, and it's all of the connections between all the different services that Netflix have. So they've got databases on there, they've got all the different microservices, and I was listening to Sam's talk this morning, and also Matthews from the BBC, and yeah, his diagrams looked maybe not as complex as this, but they were very complex between the communication between all the different services. So with all this communication between all these services, there's it's very good because you can change a very small part of the application independently. But the downside is, you've got all this chatter between all the different services. So that one's a quite cool picture, but I like the Amazon one. It's a little bit better. It looks a bit more like a Death Star. So these are the kind of communications between all the different services. The reason I'm talking about Netflix is a guy called Greg Orzel, who was one of the engineering management at that time in 2011, when most of their business was still just sending out DVDs. Actually, what I found out doing a bit of research on this, that Netflix actually, quite a big portion of their business is still sending out DVDs, and that it's actually a profit-making part of their business. So what he was trying to do was trying to build resilience into their teams, because it was kind of an afterthought. So people would develop their code, and then when they'd gone in production, then they were trying to make the resilience after that. But what he came at it from a kind of different point of view, and he wanted to do it from the start. So he wanted to build a system where the developers expected to have some problems in production. So they kind of engineered problems in production to test. So they made sure that the systems are resilient before it actually came to a production incident where people were actually dependent on the service. So instead of saying build your systems resilience into your systems, he's saying there will be breakdowns. If you don't do it, then your service will go down. So basically, the whole part about it was you've got to build your systems to survive. He built this application called Chaos Monkey, and that's where it's kind of he coined that phrase of chaos engineering, where it randomly, seemingly randomly, takes down different, in his case, servers in 2011. And that project's still going. The Chaos Monkey project's still going, and you could still download it. I mean, this is taken a couple of days ago, but the last update was 4 days ago, so it was pretty recent. They've still been working on it. So like a lot of people, I went to a conference talk a few years ago, and someone else was talking about chaos engineering, and I went out there and I thought, I know what I'm doing. I'm just gonna completely, it's simple. You just randomly destroy servers in production, that kind of thing. And my first attempts at this were probably misguided and didn't actually achieve anything. But on that journey, going through that journey of just randomly destroying servers, and then trying to figure out exactly what I was trying to achieve, I figured out what the actual end game of this whole chaos engineering and doing all this stuff is for. It's for building trust with the ops team and developers, but more than that, it's building trust between you and the business. Because if you have a resilient system that you can keep sending out releases, and each change it's okay that they're confident that each change isn't going to take down the system. Even if you put some bad code in there, maybe because you've got this kind of microservice architecture, only a portion of it is actually going to go down. And because you've built that resilience in there, that, say, if the payment system goes down, then it's okay. You can use the rest of the site and everything works okay. But until you actually test that in production, you don't know that that's going to happen. And the first time that that's tested normally is when you're actually deployed it and people are actually using it. It's better to do it at 12 o'clock on a Wednesday than do it at midnight on a Saturday night. So it just builds a lot of trust, and then that's kind of the end game. And that was the surprising realization that I had when I first embarked on this kind of chaos engineering mission. Was the end game is not to have resilient systems. The end game of kind of all of this kind of stuff, chaos engineering, feature flags, that kind of stuff. The end game of that is to build so much trust that you can even get a competitive advantage over everyone else in the area. So you shouldn't approach it like this. You should approach it like an experiment, and you should document all the parts of your procedure. So you want to say, I don't know if anyone else has had this, but at school I had this kind of thing in chemistry where you had like a worksheet, and then you had to fill out the worksheet with, what you what you were trying to do, what you think is going to happen, so the hypothesis of what you think is going to happen. So and then you document all the steps of the journey. So if you have to do it again, then you can go through the same one, and you can understand what happened at each stage. So this memo on the base of it looks a bit like, it's chaos, fire is chaos, that kind of thing. But I don't know if anybody else is like this, weird like me, that I quite like to look at the story a little bit behind some of these ones. So this girl is called Zoe Roth, and this was taken in 2004 by her dad. And I don't know if you can spot it, but in the background, the house is on fire, but everyone doesn't seem to be running around. Everyone seems to be quite calm. I mean, there's like, kind of like passers by just walking down the road, which probably wouldn't happen in a normal house fire. You'd see everyone crying and that kind of thing. So in this case here, it was a drill. So they did like a live drill of a fire. And if you look around, I mean, when we were allowed in the offices, there would be a fire alarm every single week. And it disrupted everyone's day, and it obviously lost some money because you've got people outside not doing their work for half an hour, but people deemed it's very important because they couldn't rely on, because the firemen have like probably state of the art equipment that they could practice doing this kind of stuff on, but they can't be 100% sure that all of their systems will work if they don't test that thing completely in production. So in an actual real and live environment with a real house, well, this is a derelict house, but like in a real life scenario, where you're getting the real pumps and plugging them in, and then they can run through it in a calm, ordered manner. So when the time actually does come, they can look back on this time when they did it in a calm manner, and then they can do it in the same way. So that's what that's what you're trying to achieve when you're going through all this process of doing the chaos engineering. It doesn't have to be very complicated. You can think of it a little bit more in the terms of I always try, and if there's any resistance, I try and sell it more as resilience testing rather than chaos engineering. Chaos engineering sounds like you're randomly taking stuff down, but if you kind of sell it as, we are just testing this scenario before we actually get to a point where we have to actually do this in real life, and people will want this service and they can't have the service anymore. We don't want to be running around at that point because we're going to make mistakes and we're not going to learn as much stuff. So I work at a company called Arup. It's in Central Square. For those of you in Newcastle, it's behind the train station, that kind of area. And I joined not long ago, and I really wanted to. I did a few experiments in the past, but I really wanted to kind of do it properly at this place. I kind of wanted to approach it and talk to everyone about it. And what Arup do, if some people here live in Durham, this is the footbridge that goes over the. I actually haven't been to this place, but there's a lot of people because the founder of Arup, he was involved in making of Arup. He was involved in making this bridge, and he was one of the architects that helped out in there. So he's very proud of it. He's not around anymore, but he was very proud of it. And everyone in the company is very very proud of it. But so they make some very complicated stuff that is, if it breaks, someone's going down. So this is the finished bridge. It was kind of like revolutionary at the time. It's probably still quite revolutionary just by the way it was built, because it rotates, and they rotated it together, and it wasn't really normally made in this way. So it so another one is one of the buildings that Arup helped make. Is this is the Jockey Club in Hong Kong, and they make buildings pretty much all over the world. And the reason why that they're called in Arup specialists for this kind of thing is because if there's some weird shape or some kind of design that needs to be safe, but also needs to be kind of decorative in how it's built, they normally come to Arup because they're good at what they do. And what I do behind the scenes, and what the development department behind the scenes do, is we make the software that helps these engineers make decisions about this kind of thing, because there's a lot of things that could affect how a building stands up. I'm not going to stand here saying that I know a lot about the engineering side of it. I'm more of a technologist that's come into this for engineering kind of firm, but there's a lot of excited people in this area. So one of the first projects that I've started on here is one called Gopher, and what it does is it's mainly geotechnical, and it figures out if they build some kind of building on a particular ground, different materials, is it going to slip down the bank? Is it going to sink into the ground? Is it going to subside? That kind of thing. So this is the kind of thing that we're working on. So there's some like kind of heavy analysis in the background. You've got the pretty pictures, and then you've got the heavy analysis in the background. And there's a lot of communication between a lot of services in the background. A little bit like what Matthew from the BBC was talking about this morning. There's a lot of kind of behind the scenes computation going on with this. So to be kind of successful in your chaos engineering attempts and your resilience testing attempts, what you have to do is have a very solid monitoring. So if you haven't got the monitoring there, if you haven't got some kind of observability of, is it working? Is my new release working? Is my effects on what's happening actually having any effect? Then you need to get that in place first before you can even start doing the chaos experiments. Because if you don't have this if you don't know if there's something going wrong, then you won't know if the experiment is a failure or success. So say if you're using AWS, you've got a resilience over a few different regions. I'm not sure how many people actually test if their service still runs if one region goes down. So there's tools out there that'll replicate a whole region going down, because most people think, AWS handles this, but have you got all these instances in all the different regions? So say you've got all the maybe you only have a database in one region, or you think you've got multi-region databases, but actually you've only got one region database, but everything else is in multi-region. So monitoring is pretty key. Ideally, you have some business monitoring rather than just CPU and memory and instances, that kind of thing. What you want is something that says if you're on retail site, how many kind of transactions have gone through it? Is it less than this time normally on a Wednesday afternoon, or is it, has it gone down dramatically? And then as soon as you um, as soon as you can figure out what the problem is, then you can go on the next stage. So you could say, okay, so in my Go, for example, we have an analysis, and what you want to do is try and find the very simple analysis, a simple example as possible. So you want to find the smallest bit that won't affect everyone else. If you start saying, oh, availability goes down, I wouldn't use that as the first experiment, because if you fail the first experiment, you won't be allowed to do any more experiments. Unless it's really bad, and then like maybe you'll not even be able to do anything anymore. But yeah, so in this example, I've got, will the previous model analysis fail if I can't load or contact the API? And then just saying, do previous models, are they cached somewhere on the browser? What you want to have here is something that not that you're pretty sure happens, like 99% sure that happens. You want to have what you actually think is going to happen, not something pie in the sky, like if everything falls over, it all works. That's not. You're not trying to figure out if things work or not. What you're trying to do is say, I've tested this locally. I've tested this in a dev environment. It. I'm like 99% sure this is all going to work, and then you run your experiment. So try and keep it small, the first one. And you might think this is not. You might think it's not important, but you should always try and tell as many people as possible in the business, everywhere, like the development team, other team, anyone who listen, basically, that you are going to run this experiment at this specific time. And they might come back to you and say, oh, can we move that to, next week when we're not doing this big release? Or, it might be some tiny change that you think, oh, it'll never fail. Because in the past, I've had where, I've used like an AMD machine instead of a Intel machine, because I thought that wouldn't make any difference. But actually, yeah, it went down during that time. But because I've already told everyone I'm going to do this experiment in between these timeframes, then they would say, and I also had this monitoring on. I knew about it. I was already fixing it by the time they said anything to me. And they were very okay. That everyone was okay with it, because I'd already told them everything that was going on with it. So why I'm saying keep the spec very small is because what you got to think about is the blast radius. You got to think. A lot of people in the case engineering community talk about blast radius. So they're saying, what is the worst thing that you can think that could happen in this scenario? So say I'm saying take the API down, or take out an availability zone. What's the worst thing that can happen? The worst thing that can happen is nothing is contactable and you can't do anything. So that you've got to kind of try and keep that blast radius as small as possible, and then incrementally increase your blast radius until you've got, a major thing like a database outage, or say you need to restore the database, that kind of thing, like you've lost all the data. That's probably the thing that scares most people, and the thing that's probably the most disruptive to anything. So that's got a big blast radius. But say if your bucket becomes unavailable and you're unable to deliver web pages or something like that, you've got probably a cache, and it's probably okay, and you can replace that as quickly as possible, and that's got a small blast radius. But if you up the latency slightly, that's also, you've got a slight small blast radius instead of a big one. I don't know if many of you have watched Chernobyl. It was on Sky, and it was really interesting because it was kind of like a chaos experiment that actually brought down the whole power plant, because they were just doing a safety experiment. And it's quite interesting. They were just trying to. They had papers on it. They knew, they were thinking, yeah, it's most likely going to happen. They tried this experiment before, and in most scenarios, it probably would have been fine if they'd tried it, if they'd tried it at a different time. It was just an accumulation of different errors. So I mean, they told everyone obviously about what was going on. But their monitoring wasn't very good. They just ignored some of the monitoring, and they that's it. They did it. It's in the middle of the night when not many people were working, which is a red flag. Don't do it in the middle of the night when nobody's working. They did it with inexperienced staff, which is, don't do that either. And their blast radius was huge for the risk that they were taking. So yeah, so you've got to try and avoid, you try and do these kind of things when a lot of people are there to help support you. So at the end of all this, you've done, you've told everyone what's going on. You're monitoring it. You're literally looking directly at the monitoring results while you're doing the experiment. You perform the experiment, make sure you keep monitoring, everything's fine. The line is above the danger line, and you restore everything back again, and everything's back as normal. So an important step that you might miss out at the end of that, because you're all celebrating or clapping yourself on the back, is that you might not write down what you've learned doing that. So what you want to say is in this case, we're saying the previous analysis are already visible for everything I've viewed, and the results were, the recently ones were visible, and and all the reports, all the errors were reported. So like that the connection went down, that was reported to a log aggregator. Like, so if you got Sentry or Loggly or whatever you use for that, or just CloudWatch, whatever. And then at the end, you've got to say what you learned. So this is probably the most important step that probably most people don't take the time to properly think about this is the whole reason why you're doing it. You want to know, you want to say what you learned. So in this case, the errors that were reported didn't give enough information that if you didn't know what was happening, you wouldn't be able to fix it very quickly. So then what you can do is you can go back and you can add those kind of things in. And then the next step on top of that is then you can automate that happening, and you can check that those errors are reported correctly. So then on your CI systems, you can automate, the API goes down, those errors are generated, the models are still there. So you can build all this kind of learning back into the system. So then if it stops working again, if somebody has some kind of error, then we can check to see if what our assumptions are actually true. So after all that, after everyone's patted themselves on the back and you're all happy, so I think the main kind of benefit that I've realized is that, so normally you have in Arup you've got engineers, and this is the surprising thing. Basically, this is like kind of the title of the talk, is the surprising thing that I found out about it, because I was looking at resiliency. I wasn't thinking even remotely about business advantage over anything else. So normally on all the other projects that we work on, we've got engineers and we've got developers. So there's kind of like they mix, but it's more kind of, this is what we need to build our buildings, and then the developers are like, okay, we'll try and get as close as possible. So there's a lot of domain knowledge transfer that needs to go on, and a lot of the developers that are there are past engineers, so they already have that domain knowledge. But I mean, it's not always the case, especially with a lot of the new kind of technology, microservices, serverless, that kind of thing, that you kind of need to have specialized people in the IT field, and then the knowledge transfers, then it gets a bit more difficult. So the first thing that we did was to move everybody, engineers and developers, onto GitHub. It doesn't have to be GitHub; it could be GitLab or Bitbucket or whatever other source control. I don't think there is any other ones, but if there is ones, yeah, you could, as long as everybody's in the same place and everyone can have a look at what's going on. So that's kind of the first step. So, all the engineers' code and the developers' code can kind of mingle, because engineers' day job are not to develop, and developers' jobs aren't main job to be engineers. But the code that the engineers write maybe is not um, is not production ready. So that was the original thing. So you've got on the left hand side, you've got engineers, and then on the right hand side, you've got all the developers going away. So which is good, but the problem was that an engineer would maybe write a paper, or they would do kind of their thesis or whatever, and they would come up with some new, really, really good analysis technique, or they would figure out that a specific way of doing stuff was slightly off. So what happened was that they would say, yes, this algorithm that you're using, yeah, it was fine 6 months or 2 years ago, but now we need to change, we need to update it, we need to have these new techniques in there. So, but it took a bit of time. It takes a bit of time to get that information, into requirements docs and going all the way through. What we're trying to do, what you get here, because you've got chaos engineering, and if you get to the point where everybody, the business trusts you, the engineers trust you, developers trust you, because the engineers are using this software, so they have to trust you as well. So if you've got everybody trusting you, you can do a bit like this. You can mix and match everyone together, and you can get the engineers writing production code. So you might be a bit freaked out by non-coders getting production code in there, but what I've found is that a lot of the things that the engineers want, by the time they get in production, they're either one, a little bit outdated, or two, that they're actually not needed or used very much anymore. So what you can do is, if you have such a level of resilience, and you have such a level of rate of churn of production code going in there, you can see if it works before you start refining it. So that is, I think this is the end game of a lot of the stuff, a lot of the newer kind of techniques like observability and chaos engineering. I think they all go together really well, and they all they all get to this end game where you can keep putting stuff in production until you get it right. So as long as you have good guardrails, so I think that's the main thing. As long as you, on the way to production, you've got some kind of automated checking of things like security. You've got tests in there. You can't just put random things in there. As long as you have tests to make sure that what you've got in, what you're going to deploy is going to be okay, and you're able to revert back to your previous version very quickly. Then you can get to this nirvana of engineers, people in the field, because in Arup there's a lot more engineers than there are developers, and developers' time is always at a high premium, because we can only, there's only so much each person can do. So if all these people that are helping us out, all these engineers, all these researchers, can all join in, they can all make their own pull requests. They can have some instant feedback on what's going on. We can have some, we can just get their stuff out there in production immediately. Then it's much quick. It's going to be we're going to know what is valuable and what's not valuable much quicker, and then we can always pull it back out. That good, because we've got that good monitoring now. We can always pull that kind of stuff straight back out. So that was me. So if you want to get in contact with me, there's my Twitter handle. I'm pretty much Peter J. Grainger everywhere. Maybe not TikTok. I already joined that in that one. And there's my email at the bottom there. So if you've got any questions about it, there's a really good Slack group as well, the Chaos Engineering Slack group run by a company called Gremlin. So if you're really interested in it, join that Slack group, and yeah, just message me for any details that anyone wants to go. And yeah, ask me questions if you want, and I'll try and answer them as best I can.